All right, my name is Nicholas Alt from Technical University in Munich, and I want to present to you today the ROS web controller. It's a versatile system for creating GUIs in graphical user interfaces, similar to RQT tools, but not as far, by drag and drop in the browser. We work mainly with simple robots such as the Turtlebot. Well, it's a HTML5 based thing or system, of course. No ROS is required on the client side, as Daniel already mentioned. We are mainly based on ROSbridge, ROSlib.js, and jQuery UI, so another project working with the robot web tools. Right now, we have different widgets for publishing, showing messages, parameters, services, images, and plots. The system here is pretty much determined by the robot web tools. ROS and ROSbridge, which connects to the ROS system using WebSockets and JSON. And in the browser, we run our web controller with several widgets and also compatible with tablets. Next slide. So it's available on GitHub since today. If you're interested in that, feel free to contact me. The code is still a bit messy, like typical jQuery code structure you get without any additional frameworks. So if any of you is experienced in Backbone, for instance, or some other frameworks, would be nice to talk to you. Next slide. I want to show you a demo on this video. Here we have TurtleSim running. The window on the right is not part of the web controller. By drag and drop, we create a parameter widget, which says the parameter, and on the left now a service widget, which just changed the color of our TurtleSim. The next thing is a quick way to set up a controller for this TurtleSim. Basically, you see the different buttons which send out different messages. The jitter in the video is somehow related to the screen capture. And some more widgets here showing you a topic and a plot. This is a parameter window which configures individual widgets. Now, here's a video showing a live demo on a robot. Again, we have some buttons which move the robot itself, the platform, and the PTU in it. We see the image here taken from the robot camera. It's streamed using mJPEG server right now. These user interfaces you create, you can save as a JSON file and just load in the browser, even just by bookmarks. Another short demo here. We have the dynamixels and we plot the forces we read out of them. I guess that's a pretty good thing for debugging the system. Thank you.
Hello, I'm Louise Powell. I'm an intern at the Open Source Robotics Foundation. I started my internship with the Outreach Program for Women, organized by Genome. And I was working on GZ Web, which is a web client for Gazebo, both desktop and mobile versions. So I started working on the mobile version for the internship in the Outreach Program for Women. So for example, if you're running a simulation on CloudSim, for example, you can visualize your simulation directly on the browser. It uses some technology like HTML5, WebGL, a lot of 3JS uses also ROSlib.js, jQuery UI, jQuery mobile. Next. So this is what I did for the internship. We already had GZ Web for desktop, and I adapted all the basic functionality to mobile. And always doing iteration with user tests. So we would implement something, give the users to use to see if they were comfortable with it, and then come back and change and adapt as it was necessary. I also implemented some code to simplify the meshes, because mobile devices are not as powerful as computers, so for the simulation to run faster, you need lighter meshes. So for example, you can simplify the meshes like as much as you want, according to how fast you want your simulation to run and so on. And the work is actually continuing. So now I'm still collaborating with the Open Source Robotics Foundation. and we're adding a lot of functionality to have the goal is to have as much functionality as GZ client, which is Gazebo's main GUI. So now we can insert some models. You can visualize like models transparent and so on. So we're still adding a lot of things. We're gonna add lights and so on. So there's a lot happening right now. And if anyone wants to collaborate, there's a lot of information in Gazebo Wiki and on my personal blog, or you can just look directly in the code. It's all on Bitbucket. So that's it.
Hello, my name is Mike Chung from University of Washington. I wasn't planning on attending a ROSCon before, so it's kind of super live, so please excuse any of the inaccuracies or problems. So for last month or two, I worked on this project called the RQT backdiff. A lot of times I wanted to compare two different sensors from the RQT back, and then it was extremely hard to use the RQT back to do that. So as a machine learning people, we wanted to either, for example, wanted to build a door opening detector. For example, Turtlebot is roaming around, and we want to make sure that it can detect the doors or maybe some other kind of events, and we want to lively compare, or we want to look at the data in RQT bag or something and compare the two important spots. Like, for example, when sensor data when the door is opening, and then sensor data when door is closing or something. So the conventional way that people usually do is just dump all the data in the MATLAB and then load it from there, and then try to analyzing using MATLAB visualization. Similarly for Python and so on and so forth. It's a bit difficult when you have like 10 gigabytes of data, and then when you have a lot of data, it's pretty tough. So RQT is really nice because RQT ROS bag is really nice because it reads the bag file in real time, and it's not worrying about the memory. And also it works really well with the other visualizations like RViz and all the other and RQT image view and all these other things. So I can quickly look at what the sensor data really looks like by jumping around. However, it doesn't allow me to give a nice way to compare two time points. So if you scroll down a little bit, go to our approach. So we came up with this thing called the RQT backdiff. So we implemented the diff-like functionality for RQT. What it allows you to do is you can display two RQT back at the same time. Think about like git diff or any kind of diff and then play it through and jump around to the places where you are interested in. So for example, like if I'm interested in two different time points where one is door opening and door closing, and then the other, one is one instance of the door opening, and then the other one is, for example, here, that where the red bar is like where sensor data is about door opening, and then one is door closing. Then I can play them, and then subscribe. RViz or other viewers can subscribe to two different data sensor source, and then I can visually look at how they're different. And this was really nice because I can get like intuitive idea how those two are different, and maybe even form how to build a classifier online. Yes, so that's about it. There are more smaller features I can talk about. For example, you can so what the problem is, like, you want to figure out what are the dynamic points that you're interested in. For example, maybe I have some markers that saying that these are the points that doors open and doors are closed. Then I can create some filters for extracting those time points so that I can jump around between two time points and compare. And there are some smaller features that are supported by this. And yeah, that's it. It's somewhat useful, but there's a lot of bugs. If you want to actually use it, talk to me after. Thank you. Yeah. And available on GitHub. I'll post somehow.
Hello. Hi, I'm Dr. David Hansen. I'm with Hansen Robotics, and we developed these extremely lifelike humanoid robots, such as Diego-san at the University of California at San Diego Machine Perception Lab. So my team and I built the face. The body was actually built by the Kokoro company out of Tokyo. So now there's this question, why human-like, right? I mean, there's lots of human-like robots in the world, but lots of other ones. Well, the main reason is that the human-like face is very attractive to people. That's why you see human-like faces in movies and cartoons and so forth. You see them actually used in theme parks, medical education, simulation, medical simulation robots. They're useful for these kinds of simulation and education applications. And of course, consumer products are kind of a well-known application for this stuff. This is one of, or a number of, my robots. Let's see if, seems like that the connection here is a little wonky. So you can see some of the natural looking facial expressions that my robots have generated. They've got cameras in the eyes. They simulate a full range of facial expressions. They're extremely lightweight, so they mount on walking robot bodies, such as the Hubo robot at Geist. So with the cameras in the eyes and algorithms for detecting faces, they make eye contact with you. They can have a conversation. So we set up these sort of intelligent algorithms, but also some theater in the mix. So we simulate like the sci-fi writer Philip K. Dick. We also have a natural auto tutor software that at one point from Memphis, University of Memphis, we connected with Einstein. It was teaching physics. So now that said, with all this stuff, it's been really difficult to connect in new features and extend it. So we switched to ROS with OpenCog that's been working to interface their AGI software with ROS. They're located here in Hong Kong, and we've been working with them quite a bit. We've developed also a binding between ROS and Blender, and that's the main thing that we're talking about today. With Blender, you have movie quality computer animation software. It's really come of age. It's quite mature. So you can author inverse kinematics in Maya, in Blender, and it's very easy to put the IK chains together. You can author all kinds of complex motions. Now there is a Blender ROS binding that exists in a form called Morse, but that's with the Blender game engine. It doesn't have the complete set of features with Blender. So we created a Blender binding and also with Morse, Blender simulation, sort of a replacement or parallel to Gazebo. And we're going to set up a demo in a few minutes, and you can come see a real live Einstein head that will interact with you and track this guy's face and facial expressions as a kind of telerobotics demonstration. Thank you so much.